Alright, I wasn't extremely happy with my explanation in class today, so I took some time this afternoon to create, I think, what will be a better representation of um, deriving the quadratic formula from completing the square. So just to orient you a little bit to what's going on, you see on the left, this is our specific instance of a quadratic equation that we're going to solve using completing the square. On the right is the general quadratic equation that we're going to solve, and that's going to lead us to the quadratic formula. And in the middle is our kind of graphical representation. So you see that we have 3x squared plus 8x plus 4 equals 0. So on the left side of that vertical dark line, we have 3 squares that are x by x. So when we have x by x, that means our area is x squared. So we have 3 squares of area x squared, so that's our 3x squared. Then below that we have 8 rectangles that are 1 by x, so that's an area of x. And then we have 4 small squares that are 1 by 1, so an area of 1. All that together creates the quadratic that you see above. And notice that we don't have anything on the right hand side of the bold line, and that's because we have 0 on the right hand side of our equation. Okay, so the first thing I've done is I've moved those 4 to the right hand side, so I subtracted 4 units from each side, and so now I have negative 4 units, and I've done my negative values in kind of a reddish pink color. And you can see now we're in the second step. Kind of algebraically, what we've done is we've, like I said, subtracted 4 from both sides, so we have that. We've also broken our left-hand side into 3 chunks. So the way I'm representing that algebraically is by factoring out a 3. So I have 3 versions of x squared plus 8/3 x. Now you'll notice here in my particular example that because I had 8 x's, 2 of those could fit into each of my 3, but then I needed to break the final 2 into 3 pieces, so that would be 2/3 for each. So altogether, that's 8/3. Now I'm going to adjust that last one just a bit so that it's x in length and 2/3 in height, so that I can kind of fit it in with the other pieces. So we have 3 identical pieces of x squared plus 8/3 x, and that's equal to our negative 4 on the other side. Okay, so now I'm going to start to reorganize these so that I can make squares. So you'll see here I've broken my 8/3 into halves. And you can see I took each of those 2/3 blocks, split those in half, so now I have a 1/3 x, or x over 3, for each section. So the side length of my almost squares, notice I'm missing a piece, the length of that is x plus 4/3. So I have x plus 4/3 by x plus 4/3. And what that's going to do is allow me to now complete the square. I want to put in an extra piece that fits in that missing part. So because that missing part is 4/3 by 4/3, the area of the piece that I'm going to put in is 16/9. That's 4/3 times 4/3. And notice because I had 3 pieces, I had to put it in 3 times. So now you'll see on the right hand side, I had to also keep that balanced. I added new material to my left hand side, so I needed to add new material to my right hand side. So I added 3 copies of that. And if you look at the equation, notice I added 4/3 squared inside the parentheses. So on the that's on the left-hand side. So on the right-hand side, I needed to add 3 times 4/3 squared, because the 4/3 squared on the left is also being multiplied by the 3 in the front. And from here, what I actually did is I have 3 versions of this, but really what I want to figure out is what the value of x is. So I don't need all 3 versions. So what I can do is divide by 3, and that's what I'm going to do. If I divide both sides by 3, then instead of having these 3 squares on the left-hand side, I'm going to have 1 square. And notice on my right-hand side, I have 3 green 16/9 squares, so I'll end up with 1 of those. I have 4 squares of -1, I should say, 4 squares of -1. So that value I can adjust so that 3 of them will go into each, and then I need a third more. So that's what I have here. I have my 1 square on the left. That's now, it's the quantity x plus 4/3, quantity squared. Now notice, algebraically, that's what I did before. I turned it into a square. Right? And then on the right-hand side, I have my 16/9. I have my 1, and then I have my 1/3. But those in the pink are negative values, so we need to keep that in mind. So those undo some of the positive value. So if I had 16/9 and I took off 4/3, now I'm left with 4/9. So I'm going to just readjust my 4/9 that's a rectangle into a square. So now this square of 4/9 is 2/3 by 2/3. Now remember, we're still solving for x, and right now I have, you can see at the top, I have the quantity x plus 4/3, quantity squared, and that equals 4/9. So now I can take the square root of both sides. Now, a couple of things to note here. One is that if we're talking graphically, the square root of a square is the side length. The square root of something is the side length that would give you that area. So for x plus 4/3 quantity squared, the side length is x plus 4/3, just like we've seen. Now on the right-hand side, we've been talking in terms of the positive 4/9, but a positive 4/9 area, or 4/9 value, could come from a side length of 2/3 or the side length of negative 2/3, because we see that negative 2/3 times negative 2/3 still gives me a positive 4/9. So that's why I have the positive and negative versions. Right. So as we look at that, we're still trying to get the x by itself, so we break up the x from its 4/3, and now I subtract that 4/3 on both sides. So now I have x by itself, and I have negative 4/3 plus 2/3, and I have negative 4/3 plus negative 2/3. So that gives me the solutions of negative 2/3 and negative 2. So those are the solutions for my particular specific problem that we see on the left. And on the right, we generally have now our negative b plus or minus the square root of b squared minus 4ac all over 2a, the common quadratic formula. And they were developed through the same process of completing the square. And then we can also see that as a graphical representation, the red curve for our case is y equals 3x squared plus 8x plus 4. And then the horizontal blue line, that's y equals 0. And where those intersect, where they're equal to each other, are at -2 and -2/3, where we're pointing with the arrows. So those are a few different representations of how we can use completing the square to solve, and how that completing the square leads us to the quadratic formula. I'm going to go ahead and leave this for a moment so you can look through the steps, so you can kind of remind yourself of what you're doing. So in the first step, if we're looking at the specific side, we moved the constant term to the opposite side. So in this case, we subtracted 4 from both sides. We also factored out the leading coefficient, so that 3 in our case. Then we broke our linear term, the 8/3, we broke that in half. We used that half part to then complete the square. So the 4/3 gets squared, and that completes our square. This is now the fourth line down, is where we're actually completing the square. And since we're adding new material to the left side of the equation, we need to add the same amount of material to the right side. And since that 4/3 square is inside the parentheses, that's being multiplied by 3, we have to multiply by 3 times 4/3 squared on the right side of the equation. Now in the next line, we're just cleaning that up a bit. We created that perfect square so that we could simplify to this 3 times the quantity x plus 4/3 squared. Now once we have that simplified, we can simplify our right side. In this case, our right side simplifies a lot. It's very nice. So we get 4/9. And once we have that squared, we can take the square root, keeping in mind that we have the positive and negative roots. And again, our numbers are nice. So the square root of 4/9 is 2/3. So we have x plus 4/3 equals positive and negative 2/3. And then we want to get x by itself, so we just subtract 4/3 from both sides, and we come up with our solutions. When you look at the general side, the same sort of thing's happening. We have all the pieces we need. We separate our constant term. We factor out our leading coefficient. We break the linear term in half. Use that half to square, and make sure that we're multiplying by our leading coefficient out here. Then we simplify where we can. We go ahead and use this information that's a complete square now to write it in its squared form. Then once it's in its squared form and we're simplified, this is just more process of simplifying. This is finding a common denominator here. You can look through that. Then we can divide both sides by our leading coefficient, like I did here. In this case, I actually multiplied by the reciprocal. Multiplying by 1 over a is the same as dividing by a. And that's another step of simplifying. Then we take the square root because we have this section squared, so we get the square root of both sides, keeping in mind the positive and negative. And then once we have that, we have x plus b over 2a, so we're going to subtract. And then the rest is just cleaning it up. So I hope that makes it more clear, and we'll be able to accomplish more with those problems as we go forward.